A combustion process occurs deep within the Earth. This process involves the burning of materials under extreme conditions. The combustion releases gases as a byproduct. These gases are emitted at extremely high temperatures. The persistent nature of this combustion indicates a continuous reaction. Gases within the Earth's mantle begin to ascend. The rising gases are under immense pressure and temperature. As gases ascend, they interact with the surrounding mantle material. This interaction causes the surrounding materials to melt. The ascent and melting process contributes to geological activity. The Earth's crust undergoes melting processes due to various factors. This melting leads to the creation of cavities within the crustal structure. The cavities often take the form of channels. These channels can exhibit a spiral shape. The specific shape and structure are influenced by the dynamics of the melting process. These formations contribute to the overall geological evolution of the Earth. Gases move through cavities within the deep Earth. Intense friction occurs as gases interact with cavity walls. This friction leads to magnetization of the surrounding material. The process also results in ionization of the gases. Porosities are more prevalent in weaker zones of Earth's crust. These zones are characterized by materials that melt more readily. The increased fragility of these materials at high temperatures facilitates melting. This melting contributes to the formation and abundance of porosities. Submarine vents are formed by the movement of melted materials. The movement of these materials leads to the creation of new vents. These vents are located in various regions of the ocean floor. The formation process is ongoing and dynamic. Volcano formation is a geological process involving molten material. This process occurs when molten material ascends towards the Earth's surface. The ascent of molten material can lead to the creation of new volcanoes. Volcanoes are formed as molten material reaches and solidifies on the surface. The accumulation of solidified material builds the volcanic structure over time. This continuous cycle of material eruption and solidification defines volcano formation. Earthquakes are seismic events caused by collapses of large cavities. These collapses occur at varying depths within the Earth. The energy released from these collapses propagates as seismic waves. These seismic waves are what we perceive as earthquakes. Monitoring teams have observed increases in energy activity. These ascents are specifically located in the Asia-Pacific region. The detected changes include both ascents and expansions. These energy shifts are being actively monitored. The monitoring process involves tracking the intensity of energy. The monitoring process involves tracking the geographical spread of energy. Energy ascents are monitored in specific locations. These monitoring activities occur at depths off the East Coast. The location of interest is near Honshu, Japan. The monitoring focuses specifically on energy ascents. Data visualization is employed to analyze the energy ascent patterns. Unusual energy ascents are being detected in the vicinity of Hokkaido, Japan. These energy signatures are not isolated to Hokkaido alone. Similar energy ascent phenomena are observed around various other Japanese islands. The widespread nature of these ascents suggests a potentially interconnected event. Further investigation is required to determine the cause and implications of these energy increases. The Philippines is under surveillance for potential energy expansions. Areas around Mindanao are being monitored. Depths around Leyte are also under surveillance. Luzon's depths are included in the energy expansion surveillance. The southwest region of Taiwan is under observation. Monitoring is focused on deep Earth energy activity. This monitoring likely involves detection of seismic or geothermal phenomena. Deep Earth energy can manifest as tectonic shifts or geothermal gradients. Advanced sensors and data analysis are used to track these activities. The goal is to understand and potentially predict geological events. The Kurils and Kamchatka regions are under observation. Neighboring seas around these areas are also monitored. The observation focuses on detecting energy expansions. Mapping is utilized to visualize these energy expansions. expansions from various regions may extend significantly. These expansions could reach depths near Hawaii. The expansions might also extend towards the Aleutian Islands. This potential reach indicates a broad geographical impact. The map illustrates the scope of these potential expansions. Hawaii and the Aleutian Islands represent the outer boundaries of this reach. Active foci are areas where specific activity or phenomena are concentrated. These foci can represent various activities depending on the context. Active foci have been detected in the Gibraltar Strait. Additional active foci are present in Greece, Turkey, and Italy. The presence of these foci may indicate significant regional activity. Central and southern Mexico are identified as regions with active energy ascents. The map focuses on areas including Guerrero, Chiapas, and Oaxaca. These regions are noted for specific foci of energy-related activity. The ascents suggest a concentration or upward movement of energy in these locations. Further investigation might reveal the nature and implications of these energy ascents. Central America includes several countries with active seismic foci. Guatemala is one of the Central American countries exhibiting active foci. Nicaragua is also identified as having active seismic zones. El Salvador is another country in the region with notable seismic activity. Costa Rica also demonstrates the presence of active foci. Panama completes the list of Central American countries with active seismic foci. Southern Chile, specifically the Los Lagos and Aysén regions, is under observation. This monitoring focuses on tracking energy-related activities within these regions. The purpose is to gather data and assess energy developments. This information aids in understanding the energy landscape of southern Chile. This map highlights areas with active foci in South America. Central and southern Argentina are identified as active foci. Peru is also indicated as a region with active foci. Southern Ecuador is marked as another area of interest. These areas represent key locations for observation and analysis. The U.S. West Coast, including California, Oregon, and Washington, is experiencing energy ascents. Energy ascents refer to increases in energy production or consumption within a region. This may involve renewable energy sources or traditional fossil fuels. The West Coast's energy ascents reflect evolving energy landscapes. Texas, Nevada, and Utah are located in the northwest regions. These regions are actively monitored. The monitoring focuses on energy expansions. Energy expansions refer to the growth and development of energy infrastructure. This includes projects such as new power plants and transmission lines. Monitoring helps track and manage these energy developments. The region encompassing New Zealand, Kermadec, Fiji, Tonga, and Vanuatu exhibits significant geological activity. These locations are identified as active foci, indicating areas of concentrated seismic or volcanic events. The term expansive foci suggests that the active zones are not limited to single points. Instead, the geological activity is spread across a wider area within these regions. A map illustrating these areas would highlight the extent and distribution of these active geological features. Nepal is identified as having active foci. Myanmar is also recognized as a location with active foci. The Nicobar Islands are included in the list of active foci. The Andaman Islands are similarly designated as having active foci. The Azores are characterized by dynamic geological activity. The Canary Islands also display active geological and geographic expansion. Xinjiang exhibits expansive geographical characteristics. Xizang, Tibet, is another region known for its active geological processes and expansion. Yunnan demonstrates active geological features and expansive regional dynamics.